first thing we'll be talking about is how AI, and I just came back last week from Amazon reInvent, big conference in Las Vegas, but it was very exhilarating to see all the new advances in AI and technology, particularly around software development. I feel, as always, I feel like a lot of the testing is forgotten, and so I was able to make the case when I was there at the event that quality, safety, and testing is really important, and we mustn't forget about it. And so I'm going to talk about the state of AI today. I'll talk about how we're using AI in the software lifecycle. I'll talk about what's going to change around QA and how do we ensure safety and quality. And then I'm going to go into the live demonstration of some of our tools. I'm also going to show you a little bit of one of the agentic development tools that we've been playing with as well, and how that fits into the whole equation. So first of all, let's talk about where we're going to end before we begin. I'm going to show you a little bit, a sneak peek of agentic AI technologies that let you people do development. So what we're noticing is that as people start to use agentic AI to do development, and manage the software development lifecycle, we need to think about how is that going to change testing. People are using AI to do vibe coding. They're using agents to build software. They're using things like MCP to accomplish business tasks. We're going to have AI agents that potentially are going to perform autonomous actions on behalf of the user. Now, that's going to require a whole new way to perform software testing. So we're going to need to think about how do we use testing with AI and how are we going to test AI itself. And these are two distinct but related fields. Today's presentation is more focused on how we test with AI, but I'm going to talk a little bit about how we can test AI as well itself. First of all, about me, I've been in this industry for 25 years. At the Amazon reInvent conference, they had a video with time travel, going back in time to the days of COBOL. I don't go back that far. I've been working in the industry since 1998, 97 timeframe, Visual Basic, the launch of the web revolution, mobile technologies, cloud, seeing a lot of different things, and AI is a very exciting time. We are at the brink of the next big epoch in software technology, and and we have to make sure that we understand this because we're responsible for making sure the software that we're releasing is going to be safe for people to use. There are lots of horror stories about AI, so I think having seen the industry evolve over this time, it's important for us to think about how do we have a responsibility to make sure as technologists that what we're delivering is actually safe software. It's not going to put people at risk. Now, as with any discussion around AI, it is moving very fast. Google announced new models about 2 weeks ago. OpenAI has declared a code red. Amazon released new models last week at reInvent, new development tools. So if you're watching this a month from now on YouTube, it's probably out of date. Look for a newer video. So it is going to be what is the best information we have today, but it is going to obviously evolve really quickly. So with that caveat, where are we today? Well, if you look at the AI life cycle, the journey, 2.5 years ago, 3 years ago, ChatGPT was launched and the generative AI era began. AI has been around a lot longer. I've been using it since the 80s and the 90s. Machine learning has been around for a long time, but generative AI as a consumer business application was launched in the same way that the web browser launched the internet. The internet had been around since the 1950s and 60s, but until there was a web browser, people couldn't fathom how to use it for business or technology or for consumer use other than just academic. The same thing, unless you were a data scientist, AI was kind of this black box. Well, now ChatGPT made AI something that a business user could understand the value of, and massive investment has poured into the space, as you know, since then. But phase one, which was 2 years ago, is really that digital intern. The AI is a tool that writes content for you if you're a marketing person, generates videos for you if you're a video person. If you're in the software development space, it could suggest code snippets for you, like ChatGPT. You could ask it to do something, it would write code. Copilots came around, they would do it in your IDE. But for the most part, it was generating content that you would then consume and do something useful with. And that's why we call this era the digital intern. It's like having an intern. You tell it what to do, it does something for you, and you take its output and you use it in a blog or in a compiler or on a website, depending what it is you asked it to do. But it doesn't have any agency. It doesn't try and do things other than just generate content. And this is because we have this great technology called a large language model or a generative pre-trained transformer. The real benefit we found was that instead of needing a lot of expensive data scientists to take all your data and basically model everything and build a huge trained model instead of decision trees, you could take something that someone else had done, a pre-trained transformer, pre-trained model, and if you use techniques like prompt engineering, RAG, and vector databases, you can give it a small bit of information, which is your context, and it can then use its general intelligence and figure out how to answer your question. which is pretty amazing. It's the same way the humans do it. We don't necessarily know everything, but we can reason. You give me I read a paragraph and I can reason the output. It's a similar idea. We don't have to train an AI on our entire data set. We can have a general purpose AI that knows general purpose, how to answer questions, how to research, how to think, and then we feed it our specific context. And that made AI so much more accessible to any application that needed it, which is good and bad. And that's where that began the revolution. Now, the next phase was phase 2, the digital employee. And that's where we're now talking about the beginning of agentic AI. The idea is that you give the AI agency. Not only can it write content, but it can see things and it can do things. And that's done using 2 technologies that are related to the large action model. Anthropic was the first to do this with its computer use, and OpenAI followed up with Operator. Amazon Nova has Act, and Google has something as well. And basically all the large models are now doing this. It's basically, as well as being able to write content, it knows how to click a mouse on your computer. It understands what Excel is. It understands how to open a sheet in Excel. It knows how to open up a terminal window. It knows how to download a library, maybe. It knows how to format your hard drive. It happen. It knows how to leak your production database if you've got permission. So it can take good and bad actions autonomously based on what it thinks is the right thing to do. Obviously, to be able to do things, it has to see things. And so the other big benefit was the large vision model. That's where you can give the AI a screenshot or an image, and it can reason from that image and then use that to perform actions. And when we talk about QA, this is a huge step because this allows us to do QA by seeing, as well as just by looking at a web page. It can see the image and begin to understand what's in the image. So together, the vision models and large action models give us this agentic AI, agents that can sync, that have sensors. The third era, which we're now in right now, I would say we've entered it probably at the beginning of the year, and at the end of 2025, if you're watching this, we're, I think, fair and square in this era. This is the era of teams of agents working as a team. In the same way that if you have a Scrum team, you have a Scrum Master, a product owner, you have the developers, testers, and other BAs, database, security, DevOps, all the different roles on a human team. We now have different team members on a digital team. And the technology that makes this possible is something called MCP, and there's a related protocol called ACP, another one called A2A. We won't go into too much detail of these tools, but they're basic communication protocols. The most popular and most common is MCP. The other 2 are kind of extensions of it. An MCP lets a technology use another technology. So, for example, a testing agent could talk to a development agent, and it could say, can you give me the code I want to test? The business analyst agent could say, I've got my requirements. And the developer agent would say, can I have your requirements so I can build them? And the testing agent can say, can I have your requirements so I can test them? And the deployment agent can say, can I have your developed application and deploy it for you? And the support agent says, let me look at the deployed software and see if it's going to cause any issues. So you can already see these different technologies are working together in the software lifecycle, just like a human team. And MCP is a technology that glues them together. Oops. So that's the era we're in today. So that's kind of the context. That's the big picture. That's where AI is today. Software development, of course, is really important because we're using software development to build these agents, deploy them, run them. And also we're starting to realize that as developers use these tools to do the development of AI systems and non-AI systems, it's changing the velocity and quality of what's developed. So let's talk about that. So a related thing that's gone on is called vibe coding. You've probably heard of it. Vibe coding is when, instead of me as a developer opening up Visual Studio Code or Visual Studio or Eclipse or any of the IDE, IntelliJ, for example, instead of me opening it up and saying, well, here's my user story, let me write my code, let me write my unit test, let me push it into a feature branch and let someone review it and push it into production, and let's do some testing. Vibe coding is, let me ask the AI, I want an application that can let me log in and view a list of surveys, and can write a survey. You tell it that, and then the AI can literally build you the application. It writes the code, but more than writing the code, it installs the libraries, installs the web server, writes the database tables. It will install dependencies. It will even write the README file, and it's pretty incredible what it can do. And I'll show you some of this in a minute. But it's basically a machine developer that does the coding, unit testing, documentation writing, and a whole bunch of other tasks that right now humans are doing. But the problem is, it does it once really well, but then let's say you want to change your application. You created a survey application that works very well, has 10 questions, but suppose you want the ability to have 12 questions or maybe multiple choice questions instead of drop downs, whatever it is. You then have to tell it to change the application, whereas the human developer might decide that let's not break the application, let's just make the functionality incremental. The AI will just write it from scratch. And so the next version of the application might be completely different user interface, completely different testability, and it might have a whole bunch of different bugs that weren't in the first one because it is literally a different application. So very quickly we get into this position where quality and testability become a big problem, and maintainability. So it works okay to create one-off applications to do one task one time, but vibe coding really struggles when you're dealing with enterprise applications or long-lived applications. Like, for example, Spira, one of our products. It also has a hard time working with non-greenfield code. If you're building a brand new survey app, it can do it quite well. If you took an existing code base like Spira and said, I want to add a new feature using vibe coding, the code base is too big. It doesn't get to read. The context window of most AIs is too small. Literally, the number of lines of code would overwhelm it. So it's not very good for those kind of, which is the reality is a lot of what people do is adding a plugin to a Salesforce application, extending an enterprise application. We're not just writing, throwaway apps every single minute of the day. So the new thing that's come along is interesting, and it was announced, I think it was July this year at the AWS Summit, was spec-based coding. And the Kiro tool from Amazon was the first tool to do this, but I believe Cursor and Windsurf now do this as well, and others as well. Spec-based coding is, let's say if we took the best part of vibe coding, which is the ability for the AI to build the application for me, but let's give it the structure and the guardrails of specification. And now let's have the application development tool build the application to the spec. Well, this sounds a lot like, if you go back in time, this sounds a lot like requirements management. This sounds a lot like requirements-based development. It sounds a lot like waterfall, what we used to do. And so what we're seeing in many ways is, as we start to use these tools, the move towards very lightweight, very conversational user stories almost that you get in a lot of agile projects becomes less useful when you're doing agentic AI development because there's not enough context. And so we're seeing the return of the requirements. And this, just to make it a bit more concrete, well, we got a screenshot like that later, but this is what it looks like. This is spec-based development, where you basically have an idea for a feature, and you basically can build the spec, and we'll talk about how you get the spec. In the simplest, you could go into Visual Studio Code and write a markdown file and have it build a spec for you. You could ask the AI to actually take your ideas and refine it. But at some point, you've got a markdown file which represents the spec of namely the requirements. What is this functionality? Written in good detail. A design file that specifies how you want it to be designed. Is it a 3-tier web app? Is it a mobile app? Is it a command line? What is it? How are you going to build it? What's the design criteria? And then lastly, the tasks. And these can be built by the AI or they can be written by hand. But the tasks break down the feature into small enough chunks that the AI can write it. And this gets around the big issue with vibe coding. It gets around the context window limit. If you have tasks that are discrete enough, then you can actually have the AI build that task knowing that it's got enough context without having to read the entire code base or read the entire requirements tree. Because that's one of the problems, is that the context window is still small and you can't therefore give it the entire project spec or the entire code base. It fails at that. It starts to hallucinate. So spec-based development takes requirements and tests and tasks and lets us build apps using AI in a way that is reliable, relatively safe, and makes it more maintainable. But what does that mean for human development? And a lot of people are wondering about what does that mean for developers and the role of a developer, human developer versus a machine. And I do think there's going to be a new Agile manifesto, and maybe Agile is dead and it's the return of the requirements, or maybe it still is an iterative process, but instead of it being the code that's iterative, it's the spec that's iterative. Sure. But either way, a lot of the principles in the Agile manifesto do change because we are going to see code writing is less important. Documentation is the most important thing. If you've got good requirements, a good knowledge of the code base, and you might give an application your code to document it, that documentation becomes ultimately the most important thing, the source of truth. Initially, the code is a source of truth, obviously, because that's what's running. But the documentation and the spec will over time become the source of truth. In fact, there's lots of technologies out there that will help you migrate from, say, an old technology like COBOL to modern Java, or maybe from .NET to .NET Core. We're doing some of that right now. And these technologies will take your existing code and they'll transform it using requirements as the intermediary language. Once you've done that conversion, that spec that was used to do the migration is now the source of truth. So that does mean, I think, you're going to need less time. Humans will spend less time writing code. We're not going to be doing software testing, but we will certainly be managing quality. We'll be managing the creation of code for sure. We'll make sure documentation is written. We'll review it. We won't be having as many scrum ceremonies because the AI is going to be doing a lot of the stand-ups that we would normally be doing as humans, but we will be looking after the risks. Risk management as a discipline becomes much more important. And then lastly, code reviews. Well, as we see in the next few slides, if the AI is generating application code at a 4 times its previous rate, having humans do all the code reviews is going to be a mind-numbing task and a probably an impossible task. We'll need AI tools that will do code reviews. We already have them in GitHub Enterprise that do code reviews for security and vulnerabilities. But the same thing is true for stylistic and code standards. Having the AI be that initial line of code review is going to be very important. Instead, as humans, we'll review the output from the code review. We'll look at the architecture that it's designed in the design file. We'll be providing architectural governance and design governance, as opposed to reviewing every single line of code. So that is going to be the move. As humans will move to the things on the left, let the machines do the things on the right. So if that's how software development and the software development lifecycle is changing, how does AI change QA? Well, one thing that has come up several times, if you talk to any of the leaders in this space, and since I was at reInvent, this is a quote I want to mention, you can't deliver high-quality software fast unless it has high quality. And it's a fallacy to say otherwise. If you release a product and you're the second or third to do it, the risk is always that you will be left behind by the first mover. But if that first mover delivers it fast and it's sloppy, it's got a bad user experience, and we've got many examples in the industry of this happening, then unfortunately the second or third place winner may be the final solution. So you typically have to have speed and quality. Now, every company doesn't have the luxury of time, but no one has the luxury of poor quality as well. And especially when we start to build AI into our systems, the risks are really high. I mean, there was a documentary yesterday I was watching on the news here in the US about chatbots that were being used, and people had committed suicide using these chatbots because they gave inappropriate content back. I mean, it's crazy that this stuff is being released live. And that's just what's in the news. I mean, there's so many cases of AI giving strange answers, or even non-AI systems that were built using AI where quality has deteriorated. We rely on software so much to run the world. Power grids, companies, utilities, self-driving cars, airplanes, even the business software we use, financial trading, bank accounts. Any one of these systems, if it doesn't work correctly, is huge impact on people's lives. And so if we're not testing it safely for safety and quality, then there's a huge issue. But there is a problem. Since we released ChatGPT, those 3.5, 4 years ago, oh my goodness, 4 years ago now, the quality of software has deteriorated. People are not using websites with human content directly anymore. People are not going to Stack Overflow. If you go on Google and search for something, the top hit will not be Stack Overflow that it was 3 or 4 years ago. It will be an AI overview that has pulled this content from 6 or 7 different sources, and that's what you'll be using. So even if you don't intend to use an IDE, and if you're not using Copilot, just using Google by itself, you are not going to one of the many websites that we've spent years curating and building. You're going to get it from an AI, and the risk, of course, is that it incorrectly gives you the answer. So we've seen a 300% increase in productivity and a 400% decrease in quality, which is a huge issue. But there's more issues than just that. And there's a great blog that I found, The Great Software Quality Collapse. How do we normalize software failure? The link's on the bottom. Please go to that. It's really good. And it basically talks about some of the major issues we're seeing. So I already mentioned this one, but the second one is AI code contains 322% more vulnerabilities than human-generated code. 45% of all AI code has exploitable flaws. And junior developers using AI cause damage 4 times faster. So it is more higher productivity, but I've heard of failing fast, but not quite in the way they intended. So we're seeing a major issue here where quality is being sacrificed on the altar of speed. And the other maybe bizarre but worrying thing, but I can understand why, is when people are hiring developers and they ask for code samples or they look for people to interview a technical test, if a person's using AI to write the answer to the test, the answer is trusted more than a human-generated content. So we're actually hiring for AI. So if you don't use AI in your interview, you're probably going to not get hired, which means we're now promoting the very technology that we're worried about. So This should keep me. This is what keeps me worried. Should keep you worried. So how can we make this better? So if that's the problem we're dealing with, we're dealing with the problem that developers are getting more productive using AI development tools like Cursor, like Hero. Testing is becoming much more important. And in fact, the CEO of Cursor was on the stage at a conference and said, "Oh, how are we going to test all this stuff?" That was actually a public statement. And even if we were just building regular systems, this would be a problem, but we're not. We're also building generative AI and agentic AI into the systems we're testing. So now if I run the same test a million times, it might work 99.99% of the time, but not work 0.001% of the time. And that 0.001% of the time will be the exact same application with the exact same data because it's non-deterministic. Is that acceptable? Depends on your use case. If you're building an aviation system, it's not, no way is that acceptable. Maybe 5 nines isn't even acceptable. If you're building a marketing tool, yeah, maybe that's okay. But how do we apply a lens of quality to systems like that where it's non-deterministic? So we need to basically figure out how can we get the testing and the QA to the same level of speed and cadence that it can keep up with all this code that's being generated, because they're not going to slow down. And secondly, and this is a topic for a future day, how do we test AI itself? I will leave that to the end with some thoughts on what's coming. Okay, so where are we today in terms of QA and AI? So we are able to use today AI to better plan our testing. So using Risk, we can find out where are gaps. So you can use AI to look at code bases and see this line of code changed, therefore which test should I run? You can use it to look at what requirements were implemented, what features implemented, what tests should I have. AI is good and very helpful today in finding out areas of risk and finding out what tests should be written. And especially when you combine this with a human computer team together, we can create complex applications now and test them safely as a result. So what we're saying is, if you use AI to look for to basically brainstorm and help us find additional tests, find additional cases, then it's going to make quality better. And that's the human digital team together. If you just have the computer do it on its own, then you're going to miss things, and that's going to be lower quality. Documentations, requirements, and specifications are becoming important again. So we are making requirements and documentation important. So a side benefit is, because these tools tend to do a good job reading documentation as well as code, if your application is well documented for a user, it's going to be easier to develop and easier to code. So in some ways, the feedback loop from AI could make our applications better for users. Better if the user manual is up to date, if the documentation is up to date, if the requirements are accurate and match the code. Traditionally, you write requirements or user stories, you build the application, and they diverge from that point onwards. But with AI, they need to be kept in sync. So this can improve quality. AI is going to be used to help streamline project management. We'll show you some examples in the demo. In Spyro, we can use it to analyze my requirements, write test cases, write tasks. It can give me progress report on a sprint or a release. These are really useful things that help as a project manager, QA manager, tester, really improve the project management of testing. We'll also see in Rapise, in the automation side of things, we can do things like turn manual test cases into automated test cases. Again, not necessarily without a human review, but it can speed things up. It also reduces the maintenance of a test failing. We'll talk about some of the other things that are coming as well. Right now, the ability to autonomously test an application is not really there. Now, that's controversial. Go to any conference and people will say, we have autonomous testing. That's true to some degree. Go to any website that promises autonomous testing, and it's very limited. It can go to your homepage. It can scrape your navigation like a spider, and it can click on every link. It can look at all the pages and maybe give you a good accessibility test. It doesn't know your business rules, doesn't know your workflows, doesn't know your data. It can do that basic check, and it's still valid to do that, but that's all it's doing. And it can also give it a very simple login page, and it can figure out how to test it autonomously. For the most part, it could do this for a very small number of cases. Again, valid to use the functionality, use these tools, but just know that's all they're doing. And that, I think, is the truth of a lot of this. You can use it in conjunction with other testing, just don't do it, and that's all you do. So at this point, it isn't yet possible for the AI to replace human testers for all tasks and activities. That's currently hype. And there are tools that will say you can point your application at it and it will swarm agents and test everything. Like I said before, it can do that for certain use cases. Are all my links valid? Yes. Are all my pages loading? Yes. if I can navigate to them, if it doesn't require data to get to them. Um, is their usability pretty good? Yes, it can do that too. So it definitely can give you some high level checks, but it will not test everything. And people say, oh, I should just get jobs as a plumber or a barista. Well, robots might replace that anyway, so who knows? But certainly, there's going to be lots of work for humans in the new world, but it will be that we may not be writing code anymore. We may not be writing playwright scripts or Selenium scripts or writing even repeat scripts by hand anymore. It's going to be much more a digital quality supervisor, digital delivery supervisor. We may become more product owners with digital teams behind us. So I think you're going to see the composition of a team be different and the roles you have will be different, but people will still be involved in the process. Okay, so with that being said, how do we ensure safety and quality? So in this new world that we're entering, things are a little bit different. So we have the user input, which would be, if it's vibe coding, it would be literally a prompt. If it's spec-based development, it's going to be a much richer set of artifacts. And then from there, the AI will generate the application. And if it's already a feature update, it's regenerating the application. And then that same user input, that spec, that markdown file, or whatever format it is, that the AI uses to build the application is the exact same one we'll use to design and run the tests. So the spec will include things like the test cases. It will include things like the requirements. The AI will take that output together with the application, together with its general knowledge, together with vision models, action models, and traditional playback model methods, and it will run the test for you. It will then find issues. And then when you find issues, instead of logging a bug and having a developer fix the bug, it's instead going to fix this. You or it will together collaboratively fix the spec, and then the spec will regenerate the application of the code. That's the big difference in the flow. What does this mean? It means that this is a huge deal, and I think in this diagram people get lost sometimes. The most important difference here is the source of truth is the user input. Now it could be if it's vibe coding, it's a prompt, and in spec-based development, it's effectively a series of natural language markdown files that a human can read, write, and edit. It's a requirements document. It's a test case document, test plan. We know those things. We've had them for years, but that's what we have. AI takes that stuff together with the code, and it builds the application for you. It refines the application. And then that's what's used to run the tests. But the key is, it's still iterative. When you find bugs, because you will, the AI and the humans together will refine the prompt or refine, in most cases, the spec, and that generates the code. So developers won't be fixing code. They won't be going to a line of Python and saying, let me change that line of Python. The developers are going to be looking at the markdown file and go, why did it take that markdown file? And why did it generate the application in this way and cause this bug? And the AI might say, well, to fix this bug, let me change the spec in this way. And the human's going to have to look at that and go, do I agree? Do I disagree? And the output of that will be a refined spec, updated spec. Can be version controlled, change history, audit trail, all that good stuff. Code gets generated. And the great thing then is, let's say you've got an application that's written in .NET. What if you want it mobile, iOS, Android? No problem. Same spec, different design, different UI, same spec. So suddenly it becomes much easier to do cross-platform as well. So lots of cool things it's going to enable. You're going to migrate from COBOL to Java. Guess what? Take the COBOL app, get all the specs, get all the requirements. If you can't get the requirements because they're in a PDF, that's a problem. We're going to talk about that a little bit later on, what we're going to do around that. Build the application in a modern technology stack. Modernization and migrations become a lot easier and much more native to the end target. Okay, and where does Inflectra fall into this? Well, if you think about this flow, I'm going to flatten the flow. Spira Plan is involved in the requirements and all of the spec creation piece. We'll show you that. Rapise takes all of that markdown and good spec and can then automate that. And then there are other tools. This is where Inflectra is not directly involved. We integrate with these tools. We'll show you how using MCP. Kiro, Cursor, Windshark, pick your favorite. They can do the code generation piece. Look at GitHub, GitLab, integration of CI/CD. Plenty of AI there. They're your DevOps agents. Deployment, same thing. So if you've got 5 boxes, well, you're basically going to have 5 agents, platforms, technologies, tools, all orchestrated with MCP. And at the bottom, I haven't shown it, but there's actually probably a project manager agent who is the orchestrator agent, and they're responsible for managing all this, to getting the DORA metrics, getting the analytics, measuring quality, program management, portfolio management, all of the, how does this fit into the wider architecture? That's all going to be done as well. But this is the new flow we're going to be seeing. And QA devs will have to adapt. And this is not yet fully rolled out, this is where we're heading. This is the direction of travel. And if you're not in this direction of travel, this is the future. So, as I mentioned, where are we headed? A lot of manual tasks are going to become machine tasks, right? Writing unit tests, automated. Writing API tests, you can post, why use Postman when Kiro can do it for you or Cursor can do it for you? Probably that's true as well. UI testing, I don't think we're going to be writing playwright scripts by hand anymore. We'll use tools that either do it or a tool like Rapise that does it for you. Things like that, development, same thing, storing libraries, dependency management, all that awful stuff. Code reviews, deploying into pipelines. AI is going to do a lot of this for us. We'll be monitoring it and managing it, but a lot of the individual tasks will be done by AI. But humans are still there because the key is quality is not testing and never has been. Quality is bigger than testing and always has been. Quality is about fit for purpose. An application might work most of the time. Maybe it works all the time, even if you're very good. But is it fit for purpose? Does it meet the business need? Does it deliver business value? And everyone's talking about AI, like we have to put AI in this, and no one's talking about value. Why do we need AI in this product? Maybe we don't. Maybe we need machine learning. Maybe we don't need anything, just algorithms. There's a lot of top-down pressure right now to put AI into anything to say it's AI washing. In the same way, people are using AI tools to do development. Again, maybe for that particular developer, it's not the best tool, but certainly, those are trends that are already going to continue. But as quality professionals, we need to understand ultimately what is fit for purpose in a software or hardware software hybrid system. Is that self-driving car safe to go on the road? Is that chatbot safe to give to children? Is that chatbot safe to give to adults? Is that chatbot safe, responsible to put on our website? Will it issue fake refunds that I have to honor? Will it issue damaging content that will go on LinkedIn or YouTube or Facebook, and people will complain? Will we get sued because we made a trade that was illegal? All real use cases. Talk to an interesting company that I won't mention the name of in the Netherlands, where they're doing quantitative trading, and they don't use AI to do the trading because it might execute an illegal trade. They use AI to write the code that does the trading. So they are using AI to do trading indirectly, but they never have a live execution flow because they recognize that there has to be a human in the loop to do that. So as we use AI more in our systems and we develop more AI in our systems, we need to make sure quality is managed. So where do we come in Inflectra? As I mentioned, we come in those two main blocks, the requirements and test management, lifecycle management piece, and obviously test execution piece. And our current product is called Inflectra AI. It is an embedded AI native to our Spira and Rapise platforms. Now, this is a sneak peek. I can't show it to you today. There will be webinars in the new year on this. We will be launching a completely new product called Inflectra Assure that is going to be an agentic testing tool that will test AI itself. These tools, Inflectra AI, that's using AI to test systems, whether AI or otherwise. But we are going to be working on releasing a new public alpha for a tool that will test AI to make sure AI itself is fit for purpose. More on that in the new year, but just want to mention that. So, Inflectra AI really works on our two platforms consistently. And Inflectra AI is embedded in both products. So it can do things on the Spira side, like it can generate requirements, write backlogs. It can analyze your requirements. Are they well written? Are they testable? Are they clear? Are they unambiguous? To do that, we're using the EARS standard, or Easy Requirement Syntax standard. We chose that standard because that's the standard that most of the spec-based development tools are also using. So again, back to that consistency. You've got a spec written in Markdown. It follows EARS. That will be the standard we should be testing with. Should be the standard we're building with. We can also use the AI in Spira to generate speedy scenarios, make test cases, make test steps, understand the insights on our release. Are we ahead of schedule, behind schedule? What are our risks? Risk identification. Future, what we don't do today but will do. We want to be able to extract requirements from screens and documents. As I mentioned earlier on, suppose you are working in modernizing maybe a mainframe COBOL system and moving it to a modern ERP. Well, let's say all the requirements are in these giant PDF files, which were scanned from the 1970s. Maybe you've got OCR technology, but AI can read that stuff. So we're going to be adding functionality in Aspire to read these PDFs, read these screenshots, and interpret the application and derive the business rules. And that way build not only your functional backlog, but kind of your technical backlog as well. Other thing we'll be doing is using RAG and vector database embeddings to understand more of the data in Spira and more of the relationships to be able to help you understand with the insights more than we do already. We really got some good stuff I'm going to show you, but we have more stuff coming. Automation side, today we can generate a manual automated test case from a manual test case. We'll show you that. We can do some limited autonomous testing using vision. We can generate test data. We can navigate applications. We can run manual tests automated. And we've got some analysis tools for flaky tests. I can't show all that today. We haven't got enough time, but we do have webinars from the last few weeks that show you those different use cases. What's coming in the future? Self-healing tests is the big one. The other one that's coming is framework generation. So I'll talk about those two. Framework generation is easy to understand in some ways. That's simply, as you know, in Repeats, we've got a framework for Salesforce. It knows what a grid is. It knows what a table is. It knows what a drop-down menu. It knows unique UI elements to a particular application. Now, we built those by hand, but Salesforce changes every month, or maybe more frequently. In fact, they just pushed an update, I think 2 days ago, which broke one of our, grids, and we have to now, grid controls that we match, and we have to release an update. So we're now using AI to generate these libraries. That means that, first of all, we can keep them up to date more frequently. Secondly, we can now build them for new applications much more quickly. So if you come across an application that Repeats doesn't know about, together with us, we can build a new library for that application really quickly, almost instantaneously using AI. And that means it can look at your UI of, say, not Salesforce, but maybe a different CRM system that's like it, but not the same one. It could build out a complete UI framework to handle that. Self-healing is the next thing we're releasing in the new year. That's going to be a way to fix tests that fail. Now, this has been the holy grail of test automation since we started doing test automation. We do have some self-healing and Repeats already based on algorithms, but this is going to use vision and AI. So what will happen is we're going to store with every object in Repeats not just its locator, like its XPath or its CSS or its technical way of being found on the screen, but we're going to store its business context. What is this button? What is this grid? What does it do? Why do we have it? Whereas today we might say, this is a grid, it's a table, it contains cells, it has a header, and it's got a class name of, purchase orders. Let's say that was what we do today. That's very useful for finding the grid, interacting with it. But when someone changes that grid, it breaks immediately. What if we also store with that grid, this is the grid of purchase orders. This purchase order grid lives in the tab that's called purchasing, and it lives on the accounting section of the application. And the grid has sorting, filtering, and editing functionality inline. We're going to store that context, that business context, with every single control. And now when it runs into that table, and the table's name has been changed or the ID has been changed, the Repeats will be able to say, let me open up Vision. The Vision model picks up the screen, looks at the grid, and says, oh, I know what this is. This is the purchase order grid. Let me relearn that from what I thought it was before and try it again. Oh, it works now. Let me update my locators and keep going. That way, we're not using AI to do every single step, because that will burn through billions of tokens and it will be very slow and expensive. But we use it to fix the tests that we can then play back conventionally. And that's self-healing. And that's coming in next year. Okay, so that's what we have. That's what's coming. Let's see it in action for the last part of today's webinar. This is Spira right here, and I imagine you're pretty familiar with it. I'm going to show you some. We only have about 20 minutes, so I'm going to do it relatively quickly, but show you some of the key use cases in Spira. And let's imagine we wanted to build out the spec for a new application. So how would we do that? So let's think about that for a second. I'm a brand new project manager. I'm building a new application. Well, let's say I was going to build a new banking application. I'll go in here. I'm going to create a new banking application. So I'll say add, and we'll call, online banking. Oh, maybe let's do something different. I did banking last time. Let's do something different. Online insurance quoting system. So we're going to mix it up today. So online insurance quoting system. Inflectra AI is enabled, which is good. All right, let's go into my requirements. I don't have any requirements. It's a brand new project. Let's go to Inflectra AI and see what options I have. I've got some different tools here. Okay, well, let me start by first creating my overall top-level epic, if you think of it that way. As a user, I want to be able to compare insurance quotes online. Okay, that's my user story. Actually, really my epic. So let's take that and let's drill it down one level. And AI is non-deterministic, so I've never seen before what it's going to generate. So let's see what it says. So as a user, I want to view multiple options. I want to revisit quotes. I want to be able to filter and sort, and I want to enter my insurance details so I can generate accurate quotes. Well, that makes sense. In fact, maybe this one should be above that one, but that's okay. So I've got 4 I would say features of this, overall epic or overall, module component. Now, this is still probably not enough detail to create a new application, but I can go one level further and I can say generative requirements again. So now I'm taking my 4 features that were under my epic, for example, and I'm now going to build it into hopefully a user story level. Now, obviously, if they're not low enough level, I can do the same thing iteratively until I get to a point where I feel like I'm comfortable with what it generated. Okay, that's a pretty good backlog. Let's look at this one here. So it's taken my user insurance quotes. I can view my quotes side by side so I can compare costs. I can see the provider names side by side. I can see it, fees and discounts. All right, this is a good one. I like this one. I would have thought of that one. So again, good to think about that. When I was thinking about building a backlog, I might not have thought of this. So again, would you use that tool blindly and build an application? Well, I hope not. You would use this together with, thinking about the application, your knowledge of the insurance domain. It's a starting point, and it takes what you write and builds out children. So maybe you define it down to the feature level, let it do the story development. But we'll just take this one as an example. What can we do with this now? Well, let's say we want to analyze it, because is it a good requirement? It seems pretty good, but I'm not an expert. Maybe it can give me an idea. So we have this feature where you can analyze the requirement, and it gives me a 3 out of 5. Okay, what I've done well, I've used the user story pattern. I've defined the actor and the goal. I specified the feature and the benefit. What have I not done well? Well, I didn't specify the format. Is it of how it's going to be done? Sure. I guess I didn't say a table. What's the best value? What are the related requirements? So now I can do 3 things. I can create a task for a human to improve the requirement, create a task, assign it to someone. I can create an attachment that just documents the feedback for looking at later. So really, if I'm not gonna change it now, but I want to keep a record of this feedback, I click create attachment. If I want to create a task to fix it right away, I would use create task. If I'm feeling lucky, I will use the improved description, and let's see what the AI can do to make it better. Okay, so it improved it. Let me hit save to accept its changes. And if I go to the history tab, I can now see with character highlighting what it did. So it added side by side. So I don't think it made it significantly better, honestly. So sometimes it does improve it, sometimes it doesn't. So you can sometimes use AI to help things. Sometimes it just rewrites it. So definitely you can look at what it does. But the other thing I would want to do is what are the potential risks associated with it? So let's see. Well, let's identify risks. So it's going to look at this requirement, and it's going to come up with what are the risks to do with this piece of functionality. Go over to associations, technical field features, inconsistent comparison metrics, inaccurate, incomplete data entry. That makes sense. And I can also do other things. So let me try a different one. Let's go for this one here. See, I want to see provider names. I want to view the quote amounts to compare costs. What else could I do? Well, let me think. Well, let me create some development tasks. So how would I implement this? And how would I test it? Okay, it's doing that. So it's finished. It's generated, I think, about 10 different tasks and about 10 test cases with a combined number, I think, of 46 steps. There we go. So if I now look at what it's done, it has taken my user story that I've written and maybe reviewed and improved, and it's generated out my development tasks, and it's generated out my test cases. So if we look at these one by one, let's pick that one and open it in a new tab. And let's look at a test case and open that in a new tab. How about negative scenarios? That's a good idea. Okay, so the AI has taken this user story and requirement, and it's come up with a task, and it's developed the API. So we can do that. There's even an option here if we want to create some sample code. Let's try that. Let's use JUnit. And it's come up with a sample task for me. And it also has generated a sample function, stub function, and some test code. So you can do that as well. On the test case side, if you look at this test case, it's written a negative test case, and it's come up here with some examples of negative tests. Enter no quote amounts, enter duplicate quote amounts, enter non-numeric values, things like that. So that gives you an example of some of the data fields it will test for. And you can also look at other ones as well. So the question then, because what is the value of this? Well, the value is, first of all, it did save me some time. It also thought of some tasks. If you think about this, I might not have thought about getting user feedback. Maybe I wouldn't have thought about side-by-side comparison of the different layouts. If I look over here, oops, sorry, not over here, when it comes to the test cases, these are some of the tests it came with. So the good thing is it thinks about some of the things that maybe we didn't think about, like maybe checking on a slow network, checking the different browsers, checking the high load, different languages. So it's not meant to replace the tester or test, writer, test analyst, but it's giving us some good examples. And if you would take the best of what humans come up with and these suggestions, you're going to find instead of maybe 10 test cases that I would have found, maybe there's 10 test cases I found. And of those 10, it found 6 or 7 of the same ones. Maybe it also found 2 or 3 that I didn't think of. So now we have 13 or 14 tests between us. That's going to improve our quality. So it really comes back to the whole point. If I'm just going to blindly take what the AI generates, I'm going to improve speed and productivity. 300%, 400%, absolutely. Quality is going to go down terribly now. If I use it with a human, now, as well as improving speed, we love looking at drafts. Much easier to edit a draft than it is to write on a blank sheet. The quality will go up and the productivity will go up. Now, maybe it doesn't go up maybe the productivity is not 400% or 500%, maybe it's 200%. So you sacrifice some productivity, but now the quality is higher than if you didn't have AI. And that's the important distinction is how can we use the AI to not just increase speed, also improve quality? And it really depends how you use it. And what processes you have in place, what guardrails you have in place. And so that's some of the functionality we have there. Now, the last thing I want to show you is, as well as generating content, obviously, and analyze creating risks, it can also analyze releases. And so what I'm going to do, just to show you that functionality, I'm going to go into release. I'm going to create a brand new release just for right now. And I'm going to assign all those requirements to that release, or at least these ones here. Let me go edit. Let me do release 1, fill, save. Yep, I'm going to assign. Let me also assign this test case to that release. Oh, it's already associated. Oh, he did that for me. Okay, good. So now if I go to that release over here, I can now use the AI. This is the release. It's got some requirements in it. It's got some test cases. Hasn't got any defects, but that's okay for now. Hit this button. I can now analyze the release. And it's going to tell me a summary of what this release is about, what it does, and it's going to give me top 3 risks. So this release is a major release, focusing on enhancing and managing insurance quotes. It's 0% done, no test executed. The release features significant risks in terms of both functionality and testing, as well as the challenge of starting the implementation within the remaining 31 days. So he looks at the release dates. These are the top 3 risks right now. All requirements are in the to-do status. No tests have been run, and the timeline is short with 31 days. That's pretty good. And again, this is a very simple release. There's almost nothing started. If you post it one of the releases that has test cases in progress, requirements in progress, you get much more rich information. So that's what we do in Spira. Now, before we jump into Rapise, I want to take a quick jump into development. This is the tool Kiro that Amazon has created. There are other tools like Kiro as well. Sorry, like Cursor that do the same thing. And so using MCP that I mentioned, let's say I finished my project development. I built all the requirements, did all the stuff. I've only built a small backlog. I haven't written all the test cases yet. But let's say I had done all that. What you can do is go into Kiro and you can do this. You can say, can you generate the full application spec from this Spira product? And what it does is we built some special MCP tools. This is the integration layer. Kiro downloads from Spira using the built-in tools we developed specifically for this purpose, the entire spec. It builds a requirements markdown file. It builds a design file, to test design file, did it again. And then it creates a task file. And then I told it to create a test case file because we know it, because it always forgets to, yet again, testing is forgotten. The AI is just like humans. So we create a test case file. These markdown files live here and they're just markdown. And these came from Spira. So think of it this way. My Spira AI builds is my project management tool, requirements management tool. Kiro is my development agent. Using MCP, it gets the entire spec literally in one line. All I do is, that's all I tell it, that, done. And then I told it, build the application. It built the application. It built the unit tests. It built some API tests. Installed the node server, installed JavaScript, installed all the packages, all the libraries, built the database, added the tables, and then finally it just told me, oh, build a README file and documentation. And it said, just start the thing and you've got an application. All the way on the bottom, there's my README, there's my documentation, here's my developer notes, and basically, we get to the bottom, you just do node install, and then node run, and I get a full application. So that's my development AI is talking to my project management, product owner, Scrum Master AI. And now the third part of the piece of the puzzle is the testing side. Well, in Spire, we have those exact same, the spec is basically from Spire. Spire is the source of truth of the spec. Rapise over here can take from Spire the spec as manual test cases and requirements. And to do that, I've got one I did earlier. I won't have time to run it all today, unfortunately. But if we go to it here, I have my manual test cases. And those manual test cases, come from Spira. So here's my test cases here. Here's the manual steps from Spira. So whatever the manual steps are in Spira, we have them here. And then using the feature in Rapise, this little wand, we can convert these into AI steps that look like this. Just a manual test, just another manual test. Looks like a manual test to me, but there's the AI, apart from this word AI in front of it. These are executable tests. They're not just manual. I go over here, get the AI panel. Using Inflectra AI, it takes the manual test definition, it looks at the object tree, and the key is it doesn't just generate random code. It looks at the object tree, and it looks for, do you have any modules or page objects or things that you've developed as your automation framework? And it first tries to match those. So if you've got generic things routines, it uses those first. If it can't find anything there, it then goes into the individual tests to look for individual objects, if there are any. For example, we go here, there'll be some individual objects, and or global objects, in fact. So any objects it comes across, it will automatically use those. Oh, here we are. There we go, all the objects here. So any of the objects here, it will automatically use. And so that's how it knows that this is a username. It's not simply generating random code. It's using all the objects in your object tree that you've already learned from before or that it's seen, and it builds it out. So that knows that entering the username into the username field maps to this particular action. That goes to the next one. Let's look at the next one. Setting a password, clicking the button. Check for an error, like that. It generates this code, and this becomes, and it runs it on the fly. So you can go in here, and you can do this and do play. Now, this application is actually the application that Kiro generated. So I've taken an application that was defined in Spira, built in Kiro. I can now test it in Rapise. No code anywhere. There's code behind the scenes for sure. Now, the one thing we don't do yet is when we talk about self-healing, so the test is here. The scenario is self-healing. So these are English instructions that make sense, but we're still relying on these objects. So I'm still relying here on this username, and that username ultimately is coming from an object that points to a username field on a page. So with this version of Rapise, the script, the RVL, the code or the codeless is now replaced by English, by the spec, basically by the human spec. The next piece, which is what's coming out next year, will be how do we get rid of this object? Because this object is okay, but it's brittle. Because if I change the login name, instead of it being a text box, maybe it's something else, this test would fail. We haven't fixed that with AI yet. We have other ways of fixing it right now, but the AI will fix that by using the vision model. So that's the last piece of the puzzle. The other thing we can actually do, though, is we can use it to do other tests as well. So we can do usability testing. So as well as checking the application, works, there's other things we can do which are quite interesting. If I go to a different test, that one, we can generate test data. So this test data you see here, that was all generated by the AI. You can do that by going into the AI panel, which is right here, and you can chat with Rapise. So we have a chat interface too. And that's how I created a list of books. I generated a data table. I can also chat with Rapise interactively, and it will build out the code for me, and I can then drop it in here like this. So this code was actually written by AI as well. So as well as writing in natural language, you can also use AI interactively here. And this was actually our first generation. So first generation is, let's write the chat in English, generate the code over here, And that way we're using the AI to help speed up. This is like a digital intern. Phase 2, which I showed you already, is the let's have the AI do it codelessly, which is like this. So there is no code. It's just simply this, and that's implicitly being run as code, but we're not maintaining the code anymore. Third phase will be the object trees that you see here, these things here, these objects will now become, which are like UI elements, these will become replaced by visually managed elements. So that way, when this item changes, the AI can fix it for me. And that's what's coming next year. So that's some of the cool stuff we can do. And lastly, I did mention we can also do some other things that are useful with AI even today, which is I want to be able to do what's called basically qualitative assessments. So I'm on a page, I've navigated the page, I want to be able to check on it. So using the vision engine, we can use what's called AI tester that opens up a vision query on the page. So it opens up the page as an image, and it can tell me things like, how many input fields do you see? Am I logged in? You can even ask qualitative assessments like, how does the page look? It will come back and say, it looks good. There's enough white space. Every button is easy to find. Or it might say, you've got a button that's gray on silver. It's very hard to see. The contrast is not good. Things like that. So is it in English? Is it in French? Checking for localization errors. So you can ask these queries and test for them. So we're now being able to use a test that we're playing back conventionally. We can then do image-based queries as it's running. And as I said, with the next version, we'll be able to do image-based text fixing as well. So I think we're about at time. With 1 minute, 2 minutes left. Are there any questions? Question, why is the description fields in the test cases empty? Good question. I think in our prompt, we just put them in the steps instead. No good reason, I think. Next question. Impressive. Can you tune for your org the number and types of tests and stuff like that to get consistent starter set? Not currently. We've told it to infer the number of tests by the complexity of the requirement. So we haven't yet got a lot of tuning parameters. That is on our roadmap, however. We've kind of that feedback. Also, you may notice it wrote tests every time. It doesn't say, well, you've got 5 test cases ready. I'm going to create 10 test cases. Well, let me see if any of those 5 already exist. It doesn't do that either. So there's definitely some fine tuning, or a lot of fine tuning to do. So again, we're still trying to. There's always that thing. Do we build new functionality? Do we, refine what we have? So we're focusing a lot on building new features and really getting feedback. So one thing will be reading a document, reading a screenshot, and extracting requirements and test cases. That's a new capability we want to add. Also, the ability to do better analysis, improve the release, more analysis features where we can find the insights as well, code analysis, like that. Okay, well, thank you guys. Thanks everyone for attending. Hope this was a good session. This is the last webinar of the year. Next year, we'll be doing some new webinars on more topics, most likely on self-healing tests, on the new AI functionalities that will be released next year. Plus, Inflectra Assure, our new agentic testing platform. It's not available yet. We're working on it. We're going to have a public alpha next year. We'll no doubt be doing webinars on that too. Very exciting times, however. So, have a good, healthy, holy season and Happy New Year for those people. And I'll see you in the webinar in the new year. Have a good one.